This is the Pir Smart Cam. The Pir Smart Cam is an open source DIY camera designed for you to view live footage from your phone or any other device using a Raspberry Pi and an Arduino. The Pir Smart Cam features PIR sensors so we can detect motion even in the dark, also including live footage where we can view the camera's live stream from our phones or any connected devices. It features motion notification, where we'll receive an email on the latest activity detected, and also the addition of the Raspberry Pi, where we'll be able to program any logic or any extra features we want, for example, IoT capabilities. The camera can be used as a home camera, or it can be used to let you know who's at the front door, whether you're expecting a parcel delivery, or it can even be used as an outdoor street view camera. But that's not all. The Pir Smart Cam includes an Arduino, meaning that we can add additional sensors and components such as an IR sensor, a doorbell chime, and more, where the Arduino will act as the dedicated microcontroller for handling sensory data such as the motion detected. Lastly, this project is also backwards compatible with the previous camera builds, some including a rotating motor, face recognition, and even a door lock mechanism. This video's outcome is to provide you the building blocks to expand and create your own Pir Smart Cam, whereby if you wish, you can also incorporate face recognition or object detection from the previous Pir Smart camera builds. By the end of this video, we'll cover how to build your own Pir Smart Cam, how PIR sensors work, how Arduinos communicate with the Pi, and lastly, how to send motion notifications to your email when the Pir Smart Cam detects motion. Hi, my name is Eben. I cover DIY projects on my channel, ranging from robotics to blockchain technology. Thank you to Make Magazine, and well, let's begin. So, for context, security and smart home cameras can be a great way to monitor and protect our homes while we're away. Whether you find yourself wondering who's at the door or wanted to check up on your favorite pet while at work, a smart security/home camera can be an effective solution. However, with the rise of cloud-based cameras on the market, you may feel slightly uneasy about the idea of your own video footage being stored on a corporation's cloud service. Additionally, some of these useful features such as recording or screen capture are typically hidden behind a subscription plan. But the question is, what if we can build our own smart camera with a Raspberry Pi and an Arduino featuring motion sensing? Well, this is the question we're going to answer in this video. Let's begin. The part list. What you'll need. In order to build the Pir Smart Cam, what we'll need firstly is the Raspberry Pi, a micro SD card, a Pi camera module for the streaming, a Pi power supply, a USB cable, and for the sensor electronics, the PIR sensor for motion detection, the Arduino, which will be the dedicated microcontroller, a breadboard for prototyping, additional components including an LED, a resistor, and a capacitor, and male to male and male to female jumper wires. So the question is, how does the Pir Smart Cam work? Well, let's break it into the two main block components, being the Pi camera stream, which captures live footage from the Raspberry Pi, which can be viewed on your mobile devices, and the motion sensor, which consists of the Arduino and the PIR sensor. So starting off with the Pi camera stream, this consists of a Raspberry Pi and a Pi camera module. The Pi camera stream captures live footage from the Raspberry Pi camera module and uses Flask, a Python web framework, to create a stream whereby any device connected to the same network can view the camera stream. Flask provides the bridge between Python and HTML web pages, which support Motion JPEG. Essentially, the stream we view on our devices is a sequence of independent JPEG images in a video compression format known as Motion JPEG or MJPEG. Motion JPEG is widely used in security IP cameras, and this technology is what we'll use for our Raspberry Pi camera stream. Devices connected to the same network as the Raspberry Pi would be able to visit the stream and view the live footage via the Flask web application on the Raspberry Pi IP address. You can view the previous tutorial being the Pi camera stream, which goes into the theory in more detail. This project builds up on that theory, almost like a part 2, but with a difference. And the difference is we'll make this camera smarter by adding a sensor, which in this case is a Pir motion sensor. But what is a Pir sensor? PIR sensors, standing for passive infrared sensors, are used in a wide array of sensory equipment, from automatic floodlights that turn on when motion is detected to CCTV cameras. In our case, the PIR sensor would act as an additional sensory to the camera, making the camera detect motion or the presence of a human within the sensor's range, even in the complete dark. This will be great for low visibility areas. And in this case, when a motion is detected or acknowledged, we can then trigger an event via the Raspberry Pi. For example, sending an email, turning on lights, or even triggering other IoT connected devices. But instead of using the Raspberry Pi's GPIO pins, we'll offload the reading of the infrared sensory data to a dedicated unit, whereby we can send the final output values to the Raspberry Pi. This as a result gives more processing room for the Pi to focus on the camera stream. And this is where the Arduino comes in. An Arduino is an open source microcontroller which we can program to execute a specific function. For example, turning on lights, controlling a motor, and is pretty great for prototyping. In this case, the Arduino's purpose is to read the input data coming from the motion sensor and convert it to a digital output. For example, the value of high or 1. The output value representing the motion detected is then sent from the Arduino to the Raspberry Pi via USB serial communications. With this setup, whenever the PIR sensor senses a change and detects motion, being the event, for example, we walk past the PIR sensor, the microcontroller sends this value to the Pi to trigger an action. And in this example, it can be a network related action, such as sending an email, triggering a light, or an alarm. Offloading the processing to the Arduino as a result helps not degrade the performance if we wish to add more sensors, or even if we wish to implement a more processing intensive feature, like face recognition. Right, that's the theory out of the way. Well, let's build. Assembly of parts. The build process. The following block diagram outlines the two main components which make up the Pi SmartCam. We'll start off building the Arduino motion sensor. How this works is anytime the PIR sensor detects motion, the LED lights turn on. The following shows the PIR sensor schematic that we'll be prototyping on the breadboard. We'll start off connecting the Arduino Nano to the LED. We'll then connect the PIR sensor with the middle output pin connected to digital 8 on the Arduino. Using the USB mini cable B, we'll connect our Arduino to our computer in order to program the Arduino Nano. Once connected, if you haven't already, you can download the Arduino IDE in order to program your Arduino Nano. The following shows the code we'll use to program the Arduino Nano to accept inputs from the PIR sensor, which you can find in the Pi SmartCam GitHub repo. In a nutshell, the Arduino reads the input readings coming from the PIR sensor on digital pin 8. In the setup, we'll configure the pins making pin 8 an input to read data. The loop runs consecutively during the Arduino's runtime, where in the loop, if the PIR sensor detects motion, i.e. the current state is different from the previous state, we'll write the value of 1 to this serial, whereby the value of 1 represents motion detected. Once uploaded, we can verify that we're all set up by viewing the serial monitor. You should be able to hover your hands in front of the sensor and view the value of 1 appearing on the monitor, whereby in this case your movements represent motion detected. This is the same circuit inside the 3D printed case. .py, as seen in the previous tutorials. As previously mentioned, the Arduino will be used as a dedicated microcontroller that will handle the sensory data. The main.py will be the starting point of the Python application, which runs both the camera stream and the Arduino PIR sensor comms on separate threads. On your Raspberry Pi, the Arduino board should appear as one of the two following device names. You can view the available devices connected to the Raspberry Pi by typing the following into the terminal. If we go back and view another script, the Arduino comms is the Python application that would receive data via the serial comms from the Arduino. Having a look at the code, the Python application output seen in the terminal would print the value of 1, where 1 represents when the PIR sensor state is high and the motion has been detected. We wait for any incoming data from the Arduino via serial communication. If the value of the data coming from the Arduino equals 1, we will trigger some action. And this action can be anything we want it to be. For example, an email notification, an alarm trigger, or activating any connected devices. So in summary, the Arduino reads the input values from the PIR sensor and transfer the data to the Raspberry Pi via serial communication. Right, we've now got the Pir SmartCam fully set up, which includes the Pi livestream and the PIR sensors working together. In the terminal, we can simply start the whole program by running the main.py Python script. As you can see here, we can view the camera stream. And notice how the LED turns on when motion is detected. In this example, the program acknowledges the motion, but only sends a notification after a 30 seconds cooldown period. You can find more features on GitHub, including running the camera stream automatically on boot up. Now the next section is optional, and this is building the 3D printed case for those who are interested. The 3D parts consist of a lens where the PIR sensor and camera modules are mounted. This also includes a base and the same for the breadboard. And once again, you can find the latest updates on the repo with the individual .stl files required in order to build this example. If you work on any improvements to this design, feel free to contribute to the repo. The Pir SmartCam can be configured to receive an email notification with the attached screenshot of the event or motion detected. To implement email notification, the following variables will need to be configured. You can find this in the main.py, where you can update the variables. But it's always good practice to store sensitive data in a .env file. Also, consider using two-factor authentication on your email, as well as app passwords, so you don't have to store your actual password in plain text. Once done, we can configure the target email we wish to send a notification and the camera frame to. Security of your own data is important, and it's advised to avoid using cameras in compromising spaces. Also, consider looking into adding credentials or encryption if you would like to expose your camera beyond your local network. Building your own Pir Smart camera is a great way to understand how electronics, such as sensors, can interact with the Raspberry Pi. This is just the start, and it can expand well beyond just PIR sensors. For example, controlling motors, as well as even building your own camera stream with an audio component. You can find more information on the performance of this Pir Smart camera in the Make magazine article equivalent, as well as the next steps. The option for an open source camera stream with motion detection and the ability to add many more features provides a DIY alternative to the tightly coupled big tech security systems. And the additional benefit is that you're in control of your own data. My name is Evan, hope you found this useful, and thanks for watching. Stay awesome. Peace.